Okay, so let's do an example using the binomial probability. So here, suppose that the survival rate of those infected by COVID-19 is about 67%. So suppose we randomly select 15 patients with a disease. Okay, so notice there's two different things that we have here. We have a probability of success. In this case, a success is a survival rate. Okay, and then we have a certain amount of patients, which is 15. Okay, which is kind of the same thing as this thing. You have our number of trials, which is going to be 15 patients. So your probability of success of survival is going to be 67%. Okay, so we know that this is going to follow some sort of binomial problem. So here, what is the probability that exactly 10 of them will survive? So notice that here, the key word is going to be exactly. So what we're going to do is we're going to go back up. What should we use when we have exactly? When we have exactly, we're going to use binomial PDF. Okay, so here our n value, let's just go ahead and write it down. N is going to be equal to 15 patients. And the probability of success is going to be equal to, let's write this as a decimal, 0.67. Okay, so the probability of x is going to be the number of patients that survive, equaling 10, is going to be equal to binomial PDF. Okay, in this case, our n is equal to 15, our p is equal to 0.67, and our x is equal to 10. Okay, so when we have this, what are we going to do? So let's go into our directions. And it says that the first thing you're going to do is press second data to obtain the stats and regression distribution menu. And then we're going to go down to distributions until we find binomial PDF. Okay, and then keep going and then just plug it in. So let's go ahead and do that. So let's go into our calculator. Okay, so hopefully my calculator, you can see it here. Okay, so the first thing that we're going to do is we're going to go ahead and press second data. Okay, all right, so we press second data. And then the next thing that we're going to do, we're going to go over to distributions. Okay, and then we're going to go all the way down until we get binomial PDF, which is right here, number 4. Okay, then we're going to press enter. We're going to press enter for single. Single, we're going to leave it as is. The number of trials, we had 15 patients. Okay, the probability of success, I forgot what that was. What was the probability of success? Not that. The probability of success was 0.67. Okay, so it's 0.67. And then x in this case is going to be equal to 10. Okay, so we're going to put that in there, calculate, and let's round to 4 decimal places, 0.2142. So this is going to be 0.2142. This is going to be the probability that exactly 10 of them are going to survive. Okay. All right. Now, what is going to be the probability that all of them survive? So if all of them survive, that means all 15 patients are going to survive. So we're going to have the probability of x equaling 15. Since it equals that, we're going to use still binomial PDF. Okay. And it's going to be equal to 15. P hasn't changed, it's still 0.67, and then our x is going to be equal to 15. So we're going to go back to my calculator. Okay, we're going to go ahead and press second data. Okay, and then we're going to do go to distributions, go down to a binomial PDF, and then everything's going to stay the same, and we're going to change this x to 15. We're going to go down to calculate. Okay, and we're going to get 0.0025. So this equals 0.0025. That is my answer. Okay, now we're going to go to the next one. So in the next one, it says, what is the probability that 7 or less survive? Okay, so now we have 7 or less. Okay, so we definitely want a less than here. That's a less than symbol. Now, are we including the 7? Yes or no? Well, yeah, because we're including, it's going to be either 7 or everything that's less than. So 7 or less is going to be less than or equal to. So what function should we use when we have less than or equal to? So if we go back up to my thing. So when you have less than or equal to, we're going to use binomial CDF. Okay, CDF just means cumulative, so we're adding up the probability. So we're going to use binomial CDF. N still is 15. P is going to be 0.67. And x in this case is going to be equal to, well, we're equaling the 7. So we're starting at the 7 and then going down. Okay, so we're going to use binomial CDF. So let's go ahead and use our calculator. We're going to press second data, distributions, go down to binomial CDF, which is going to be right below binomial PDF. We're going to press enter. N stays the same, P stays the same, and then X now is going to be equal to 7. Okay, we're going to press calculate, and our answer is going to be 0.0837. So this is going to be 0.0837. Okay, so now we're going to go to part D. And in part D, it says, what is the probability that less than 7 survive? So we have the probability that less than 7. So in this case, we just want less than. We're not including that 7. Okay, so notice that it's still less than. We're still using binomial CDF. Okay, N is equal to 15. P is going to be equal to 0.67. And now in this case, because we're not including the 7, well, what's the next number that's less than 7? Well, in that case, it will be 6. So here our X is going to be equal to 6, not 6.9, because we can't have 6.9 patients. Okay, so let's put that into our calculator. Notice that it's still binomial CDF. So second data, distributions, go down to binomial CDF. Okay, enter. Everything is going to be the same, but now this is going to go down to 6. Okay, and then we're going to go to calculate. Okay, so it's going to be 0.0289. So this is going to be 0.0. Oh, what happened? 0.0289. Okay, so that's what that's going to be. All right, so now we have 2 more problems to go. So what is the probability that more than 10 will survive? So we want the probability that more than 10, let me make it a little smaller. Okay, so the probability that more than 10 are going to survive. Is the 10 included? No, because we want everything that's more than 10. Now, can we do something that's greater than? Well, if we go back up, notice that binomial CDF will not do greater than. It only does less than. So when it's greater than, you're going to have to follow these directions. In this case, we have the second case. So what we're going to have this following thing. So we're going to write probability of X being greater than 10 is going to be equal to 1 minus the probability of X being less than or equal to 10. Okay. So notice that the sign switched and we're going to put an equal to. And then once we find that, we're going to subtract it from 1. And that's going to give us everything that's greater than. So we can't do anything with the 1. This thing is just a binomial CDF because it's less than. It's going to be N equals 15. P equals 0.67. And then X is equal to 10 because it's including the 10 in this case. Notice it's not including it over here, but we're including it here, and then we're subtracting it from 1 to get the other thing. So we're going to have 1 minus, let's figure out what this thing is, okay? So it's going to be, whoops, that's wrong. So you're going to do second data, distributions, down to binomial CDF. Everything's the same, except this one's going to change to a 10. So that's going to give me 0.5851 or 0.5852. This is going to be 0.5852. And then all we have to do is just subtract these 2 numbers out. So let's go ahead and go to our calculator. 1 minus 0.5852. That's going to give me 0.4148. Okay. And now we're going to do the last problem. So what is the probability that 10 or more survive? So the probability of X being 10 or more. So more than 10, or it can equal 10, okay? Because it's 10 or more, okay? So notice again, we have a greater than. We can't quite do a greater than, so we're going to do 1 minus the probability of X being less than 10. Okay, notice that the sign switches, and then there's no equal sign. So this is just going to be another binomial CDF. Binomial CDF. N is going to be equal to 15. P is still 0.67. And then X is going to be equal to not 10 because it's not including it. So we're going to go down 1. That's going to be 9. So you're going to do 1 minus binomial CDF. So let's go into our calculator. Okay. Second data, distributions, down to binomial CDF. Okay. And then you're going to do 15.67, and then you're going to change this to a 9. Okay, and we get 0.3709. So we're going to put that here. So 0.3709. Okay, we're going to go back to our calculator and do 1 minus 0.3709. And that's going to give us 0.6291. Okay, that's your answer. So the main thing about these problems is you have to actually think about them. You have to make sure that you understand when is it going to be greater than or equal to, when is it going to be less than or equal to. And what I'm going to do, I'm going to give you guys a little chart to kind of remember them, or some clues to try to figure out what they kind of look like. In what scenarios you should put a greater than or a less than, when is it included, when is it not included. But as long as you have this thing right up here, you should be okay. Remember, look for the keywords. Exactly means this. Binomial, that's going to be binomial PDF. Binomial CDF is always going to be less than or equal to. If you have greater than or equal to, you're going to have to do 1 minus the less than. So as long as you have this portion, you should be able to do these problems.